Okay, here we have a center of mass problem. So, a 5 kilogram cat is alone in a 25 kilogram boat for some reason. The center of the boat is 10 meters from shore, and the cat is 11 meters from the shore. If the cat walks 0.5 meters across the boat and toward the shore, I should have specified, how far away from the shore will he be? Okay, so the key to solving this problem is going to be just a perfect picture. The picture is everything to help you get the equations correct. So let's start with that. Or well, before that, let's just mention that I really want the answer to be 10.5. Right? The cat was 11 and it walks 0.5 and toward the shore. So the reason it's not that the cat's not going to get 0.5 meters closer to the shore is that although the cat's walking toward the shore, he's walking across the boat, and the boat will move away from the shore slightly. Okay, so the answer is going to be some combination between the distance the cat walks toward the shore and the distance that the boat moves backward away from the shore. Okay, now for that picture. Okay, so here's a picture of the cat standing there, and now we need to start labeling things here. Now, this is a center of mass problem, because I say so. I mean, we don't have any velocities, any forces, anything like that. We've got masses and we've got distances. Pretty much leaves center of mass. So I'm gonna need to define these positions, which means I'll need an origin. I'm going to put it on the shore so that my x-axis is going to point this direction, and right at the shore is my x of 0. So this picture is before the cat walks. This dot is the center of mass of my boat. I'll call the x value x, b initial, and the cat is at some value as well. We say the cat's location, that's probably we can say that's the location of the cat's center of mass. So the xc initial. Alright, so there's a couple of good values. Another useful value is going to be the center of mass of both of them together. That'll be somewhere between them. xcm. Okay, well I curved that over a bit. So, like in all problems, we need to list out our knowns and unknowns. So, we know the mass of the cat. So, let's see. Knowns. We know boat mass. Okay, we know initial cat position. We know initial boat position. And, did I spell something wrong? No. And we know, what else do we know? We know the distance the cat walks across the boat. I'm just going to write that. Distance cat walks. Okay, so we can try to see if we've identified these variables. Initial cat position, well, that is the xc initial boat position, xb initial. The mass of the boat cat, the cat's mass and the boat's mass, well, we haven't put them down yet, but let's call them m of c and m of b. Okay. Now, as for the distance the cat walks across the boat, I'll need another picture to start conceiving what that is. Let's see, get a little bit in here. So next, in the next instant, okay, so I've drawn the final picture. Oh, geez, it's kind of hard to tell, but I had the boat move further back. Maybe the boat's a little bit longer. So the boat moved back, the cat moved forward. Now here the first big trick to solving this problem is the center of the mass does not move. Okay, because there were no external forces on the cat and boat system, so its center of mass can't have moved. So that is going to be a useful problem solving technique for us. Before we move on to the math though, we should figure out how the distance the cat walked across the boat comes into our drawing here. So let's take a look. So the distance the cat walked across the boat will be, well, first he was some distance from the center of the boat, say D1, and then after walking he's some new distance, D2, right? He's closer to the center of the boat after walking there. And so the distance the cat walked is going to be what I labeled D1, the long one, minus D2, the short one. And let's call that a big D. And that is what we know. D. But I just made up D1 and D2. So that won't exactly help us until we figure out what D1 and D2 are. So, well, we can check out our drawing. We already labeled all these x values. D1 is going to equal xc initial minus xb initial, right? The distance all the way to the cat minus the distance to the boat gives us that D1. And D2 is going to equal xc minus xb for the same reason. So D is actually going to be D1 minus D2. Distributing this out. Okay, so finally we know what that means, what the distance the cat walks across the boat means. All right, now as usual I have gotten all wound up in this problem and I forgot what I'm even solving for. So if we look back, we're looking for how far away from the shore the cat will be in the end. And if you look at our picture, that will be xc, right? The final position of the cat, xc. Not xc initial where they started, but xc where he finished will be his position. So it will be his distance from the shore, since the shore is an x of 0. So we need to set our sights on finding xc. Well, let's see if we can do it. We know d, we know xc initial, we know xb initial. We're looking for xc, but we don't know the final position of the boat. That was not given. So we have one equation and two unknowns that we can't do it. We're going to need another equation. Now remember, I said that the center of the mass is not going to move. That's what's going to get us our other equation. Oh, so recall that the center of mass between two particles, or two other centers of mass, the cat and the boat, will be the mass of the cat times the position of the cat plus the mass of the boat times the position of the boat divided by the total mass. So that's for the final case, but since the center of mass is not going to move, I know that it will also be the mass of the cat initial position of the cat plus the mass of the boat initial position of the boat over the total mass. So this is the initial center of mass equation. This is the final center of mass equation. But we know that they're going to be equal because there were no external forces. So looking at just the second two terms here, I can multiply through by total mass, and it goes. And just to be a stickler, I'll change this a little. But what we're looking at is mc mc xc plus mb xb is equal to mc xc initial plus mb xb initial. So let's look at this now. We know all the masses, we know the initial positions, but we don't know xc or xb. So here's another equation with two unknowns. However, if you look at the equation we examined a moment ago and this equation, I have two equations and two unknowns, and so this system is solvable. So let's go through the algebra of doing that. We're looking for xc, so I'm going to take that d equation here, and I'm going to rearrange it like to solve for xb. Okay, and now I'm going to plug this xb in to the equation I got from the center of mass. Okay, so I had this equation up here, and for xb, I plugged in the expression of xb we got from the previous equation. And now I'm looking at this, an equation with only one unknown, xc. So we need to solve for that now, just some algebra. I'm going to expand out this term here. So you can check that this is correct. Now I'm going to get all this stuff with xc on one side and everything else on the other side. And while I'm at it, I'm going to factor xc out. Oh, it's looking kind of messy, but we're getting there. Alright, let's see. Let me clean up the other side a little bit. I've got a common xc and a common xb. Oh, for that matter, I have mb xb initial minus mb xb initial. So that goes. And over here, I can factor out the xc initial. Still have that minus mass of the boat times d. And so it looks like xc is going to equal okay, so I divided over this mc plus mb. It canceled out in the first term, and here it is remaining in the second term. So this is going to be the answer for the final position of the cat. I will leave it to you to plug in numbers if you wish. I hate that part. So there we have it. We solved this one using two equations and two unknowns. Now, the fact that the center of mass did not move is interesting, but that was not really the hard part if you ask me. The hard part was figuring out how that fit in, how we labeled that. And see down here, that is not obvious to me. D equals all of that. Now, I got it step by step from the picture, and I hope you followed me, but yeah, I'd be lying if I said I got this one right on the first try. Finding that how that D fits in is tricky. When we did, it was an important equation. It was one of our two equations. The D equation here, and the equation we got from our center of mass not moving. Combining those, I used substitution, and here is the solution that I get in the end. The final position of the cat is equal to the initial position minus some positive value. D was a positive value. This is, of course, going to be positive. They're masses. And so it looks like it's going to be a smaller number than it was before, which it should be. The cat was out here at some distance, walked closer, the new distance should be smaller. Okay, well, good luck to you, intrepid cat, and that is this video.